Hi everyone, welcome back to my YouTube channel. Today's video will be on my technical seminar topic, that is incorporating cloud native architecture and DevOps culture to improve the company agility under the guidance of Professor Maria Naveen J.R., Assistant Professor, Department of ISE. Contents include introduction to the topic, related background, working implementation, future enhancement, conclusion, and the references. Introduction. In today's era, driven by the technology, the organization or the companies will be seeking methods to increase the speed of their company's infrastructure process in order to maintain their advantages in the competitive world. Accelerating these software development life cycle of a company, this can be achieved by adopting a cloud native architecture and embracing a DevOps culture where DevOps, that is the development and operating system together. CNA allows the companies to utilize the capabilities of a cloud computing to accelerate the application's development and deployment. The use of the CN in the organizations has many advantages. One can, which we can tell is that it may increase the company agility. DevOps practices improves collaborating between the software development team and the IT. DevOps enforces the communication between both of them to give the faster feedback to each other. DevOps wants the IT organization team to move on for the same flexibility and at the same speed as the development team. DevOps can also increase the company agility because by using the DevOps application development and infrastructure, it may become faster. Benefits of both CN and DevOps includes combining them together in a case study. We will examine whether implementation of a CNA and fostering a DevOps culture can speed up the software development lifecycle process of a company that currently does it manually. The company involved in this case study is a electrical vehicle sector. The company focuses on building a stable and reliable digital economy system for the electrical motorcycles. The new concept involving CNA and DevOps, it is called infrastructure as a code, as an efficient solution to the automate infrastructure configuration set up while minimizing the potential risk associated with the human errors. The company currently runs its system on the cloud that is manually managed. This cases the provision and configuration of the servers in cloud computing to be less efficient and risky. Our target is to measure the impact of implementing both CNA and DevOps on its SDCL time. It is done by comparing the duration it takes for infrastructure provision and application deployment through automated various manual methods. Related background. There is a one-day observation carried out at the company. This involves closely observation and documenting various activities related to the software development. Additionally, interviews were conducted with the key individuals within the company, including the head of the engineer and other team members. After concluding the observation and the interviews, map the company's issues with a fishbone diagram where it has a 4 stages. It includes process, technology, human resource, and documentation. In processing stage, there is no proper standardization, no change management, and too many infrastructure variables to configure. In in human resources, there is a dependency on the specific personnel, lack of training and experience, inefficient internal communication between the DevOps and the operation teams. In moving on to technological team, there is lack of automated provision tools, lack of automated testing, and lack of application deployment tools. In documentation, there is no proper templates to store the documents, so that leads to lack of documentation. By analyzing all these issues faced by the company regarding the provision of the infrastructure and the application development, which is currently proposed manually and hindering process for the company. This company adopts a CNA with a DevOps culture, proposes architecture, includes a utilization of infrastructure as a code, version control system, and continuous integration and continuous delivery as dissipated. So the workflow of the infrastructure provision, where it starts with a lead developer, where the lead developer will request for the infrastructure and send that request to the system which is stored in the version control system. This version control system, it will send that request to the infrastructure engineer, where he will review the request. If the reviewed request, if it is approved, then it automatically creates the cloud and the infrastructure. When this request is not approved, this does not process. So that we have the second workflow, that is application deployment and infrastructure configuration, where it is a two-stage process, where it starts with the developer. The developer will create an application code, and that code is being sent to the system for saving, that is stored in the version control system, and that system request is being sent again to the developer. That developer will send the request to the team lead to review the code. If the code it is approved, then it creates the infrastructure in the cloud application. If it does not been successful, it configures the changes request. That request has been again sent to the system, and that system it will review the infrastructure changes from the infrastructure engineer and then approve it, and the updated request results is being stored in the cloud infrastructure. This is a workflow. So the results of this are the time required in the infrastructure provision and the deployment application. Before implementing, it takes 3 days of time. Now it takes 1 day. Server configuration drift occurs only one time. Now it does not occur, so it has a more accuracy. Change of the document needed. Here no proper documentation because of no proper templates. Here it is automatically recorded by the version control system. Time required to fix the issues. It takes too much of time to solve the troubleshoot problems. Here it is faster and rollbacks to the continuous integration and delivery. Human resource management, it requires human resources on the maintenance for the infrastructure. The new process, it is a serverless and managed by the web server, that is AWS. Conclusion: the company can leverage the flexibility, scalability, and responsiveness offered by the cloud computing that helps to improve the efficiency in infrastructure provision and application deployment, reducing the time required by up to 67%. Furthermore, by adopting the DevOps culture and practices using the IAC, VCS, and CI and CD, that is continuous integration and delivery, companies can achieve automation, consistency, and higher speed in managing the infrastructure configurations. That helps to reduce the human errors, enhance the team collaboration, and accelerate the deployment of the code and configuration changes. This study was successful in demonstrating the CNA with combined with the DevOps culture within a company to improve the efficiency, standardization, and documentation. Apart from these, the use of these infrastructure as a code and others has been proved useful to support that combination. The results of this research can be considered by the other companies who want to increase their agility in terms of the provision of the infrastructure and application deployment. Future enhancement. The enhancement of these will include the case studies of the other companies in the industry that will enhance the approach of the border applicability. Further studies that focuses on the security and cost implementation that may benefit for understanding these proposed approach more deeply. The long-term effects and sustainability of the implementation can also be studied in future. A study that incorporates the feedback for the end users or information technology staffs affected by these changes could provide a more human aspect to the technological transactions. These are the few references. Thank you.